to study discuss about the rusting as a slow redox reaction. As we know, rusting is a corrosion of iron metal. Okay, this corrosion is most common corrosion in all metal. Okay, and we start with the first point. Okay, we start with first point, rusting. Okay, rusting is an example of what reaction? Example of slow reaction. And the basic condition that require for the rusting process is what? The presence of water and the presence of oxygen. And the chemical name for rust, okay, the chemical name for rust is known as hydrated iron 3 oxide, and the chemical symbol will be Fe2O3. We will represent the dot. If hydrated, we must put dot XH2O. Why we put the X? Because we don't know the concentration of water molecules or an oxygen that attach on the rust particles. It depends on the concentration of water and oxygen molecule. Now we have to do general equation. How to do the general equation for the rusting process? I'll do here. Okay, so we try to do general equation. Okay, we try to do general equation for rusting process. The rust, okay, the chemical name for rust is what? Hydrated iron 3 oxide. And the symbol, what is the symbol for, okay, rust is known as iron Fe2O3 dot XH2O. And how to do the general equation? So I'll put iron. We need iron in the presence of the basic condition, which is oxygen, okay, and water molecule. As I told you guys, you must remember the hydrogen water molecule, the concentration of water molecule we don't know, so we have to put X symbol. It's react. Okay, you get hydrated iron 3 oxide. So I'll put here Fe2O3 dot XH2O. Now, how to balance this equation? Let us balance this equation. So I need to put 2 here. Calculate iron. 2 times 2, 4. So I'll put 4. Next, we calculate the number of hydrogen atoms. 2 times 2. 2 times 2, 4. So I'll put 2 here. 2 times 2, 4. Okay, so we make it 4. Okay, the last part we need to calculate oxygen. So look at here. So oxygen 2 times 3, 6. And we time here 2. So total will be 8 oxygen atom. So I already have 2 oxygen here. So I need some more 6. So how to get 6 here? 3 times 2, 6. So this is the general formula for the rusting process. Okay, now we try to look at this question. Yeah, try to discuss the essay question, how to based on the diagram shown below, describe the rusting of iron. So we have to draw this diagram. We have to label 2 terminal P, Q, okay, and P. Okay, at the edge of water droplet, we put P. At the edge of water here, at the middle center of water droplet. Okay, so the center of water droplet, the oxygen molecule is blocked by water droplet, and this will become A, this becomes C. And basically this rusting process is a chemical. Must remember, chemical process. When chemical process, the energy change will be chemical energy converted into electrical energy. And the anode, okay, act as negative terminal. The name of the process that occur at anode is known as oxidation, and while the cathode will act as positive terminal. And the name of the reaction occur at cathode will be reduction. When oxidation and reduction occur simultaneously, the reaction is known as redox reaction. So how to describe this essay equation and how to get the 10 marks. So I need to draw this diagram. After I draw, I need to label. After I label, I'll start with Q. So this Q, I'll put here. The region around Q will act as anode. Why this region act as anode? Because here the oxygen molecule is blocked by the water molecule. Oxygen gas is blocked by water molecule. So this is because this region, the region where the concentration of dissolve oxygen, is lower, will act as anode. The name of the process that occur at anode will be oxidation. And how to write the half equation? The iron atom. Here we have a lot of iron atom. This iron atom will undergo oxidation process where Fe, become Fe2 positive. The ion will lose electron and will turn into iron 2 ion by losing 2 electron. Once it's lost electron, the ion 2 ion, the ion 2 ions will dissolve in the water droplet. So we go for move on to next part. Region P will act as cathode. So where is the region P? The region P is here at the edge. Edge of water droplets, will act as cathode. Why this region is act as cathode? Because the concentration of oxygen and water, the concentration of dissolve oxygen at this region is higher. And what is the name of the process? The name of the process that occur at region P or cathode is known as reduction. And which molecule? So how to write the half equation? I'll do here. How to write the half equation? The basic condition or the oxygen. You can remember basic condition is oxygen and one more basic condition is water. And what is the name of the process? Reduction. So reduction involve gain electron. And what is the product we will get? So we try to look at the product. And we try to do this one. I'll move on to this one. What is the product? You have to remember this electrolysis process. We try to do revision. Electrolysis process is a process. The energy change will be electrical energy converted into chemical energy. And when we have carbon electrode, this electrode is known as inert electrode. That means we have factor 1 or factor 2. And we check the sodium chloride solution got 4 ion. So what are the name of the ion? Write the formula of the ion. So the sodium chloride symbol, sodium NaCl plus water. So I'll take first ion, sodium ion, second ion, chloride ion, the third ion. From the water molecule we have hydrogen ion and hydroxide ion. So I put here hydrogen ion and hydroxide ion. So the solution basically has 4 ion. Now in this solution, so what is the factor that involved in this reaction? So will be factor 1, which is position. So the factor will be position of ions in ECS. So we try to move the ion to the anode and cathode. So which ion will be attracted to anode? Anode is positive terminal. Positive will repel. Positive terminal, it will attract negative ion. So I arrange the ion according to ECS, electrochemical series of ion. So the position of hydroxide ion will be below chloride ion in the ECS of RNA, electrochemical series of ion. So which ion will be selectively chosen to be discharged at anode, okay, will be the ion that placed at the below, okay, at the bottom of the ECS, so which is hydroxide ion. So how to write half equation at anode? We try to check how to write half equation at anode. So what I try to do, I try to draw, okay, I try to draw electrode. Okay, this electrode is anode, positive terminal, and you must remember when hydroxide ion, please remember 4. So I put here 4 hydroxide ion. So 1 hydroxide ion, okay, 2 hydroxide ion, 3 hydroxide ion, okay, and 4 hydroxide ion. Each hydroxide ion will donate 1 electron, 2 electron, okay, 3 electron, and 4 electron. So that means each ion will donate 4 electron. Okay, after they donate, they become neutral. Hydroxide, OH, we have 4 hydroxide here. Okay, so what will happen? The neutral particle here, they cannot repel, yeah, they will repel each other due to their same charges. Here, once they become neutral, they will collide. So this one will break, go here. This one will break, go here. They will form 2 water molecules. So I'll put 2 H2O, and this O bonded together and form oxygen. So this is the equation you will get for the electrolysis process. Now I move on to the rusting process. We try to check the equation here. Okay, we try to check this equation here. Okay, so you see here we have oxygen. So this is oxygen. This is water molecule gain electron. So here oxygen, 2 water molecules. So I put 2 water molecule. Okay, and they lost here 4 electron, here gain electron. So what is the name of the product you will get here? Okay, what is the name of the product we will get here? So will be 4 hydroxide ion. Just change this one as a you just need to turn, okay, make it reverse. So I'll repeat again how to write half equation. 4 electron, and the product will form is hydroxide ion, 4 hydroxide ion. And this hydroxide ion, the hydroxide, okay, ions will dissolve in the water molecule. And what will happen next part will be iron 2 ions, okay, iron 2 ions and hydroxide ions will fuse together to form iron 2 hydroxide, and it's a green color precipitate. So initially we will get green color precipitate. And how to write the half equation? So we have here, not half equation, sorry, we how to write ionic equation for when the iron 2 ion combine with hydroxide ion. So I take Fe2 positive combined with hydroxide ion. Okay, we get Fe bracket OH2, iron 2 hydroxide. The name of this green precipitate is iron 2 hydroxide. Okay, and how to, we need to balance the equation. Here got 2, so here got 2. So how to balance this equation? I put 2 here. Okay, and this iron 2 hydroxide, okay, iron 2 hydroxide will further oxidize to form Fe2O3 dot XH2O, and this is known as hydrated, okay, iron, okay, 3 oxide. Okay, cool. Okay, so we repeat again, or we revise back what we learned. Okay, let's revise back what we learned in the rusting of iron. Okay, so basically this is the rusting of iron. So we students must remember the basic condition. So what is the basic condition? So we revise what we learned in this session. So rusting is a slow, redox reaction. And the basic condition required for the rusting process.
The basic condition that required for the rusting process is a presence of oxygen and also presence of water molecule. And how to write the F equation at anode? So this will be anode. So anode Q region will be anode. Why? Because the concentration of dissolved oxygen at this region is lower. So we take Fe. So I'll take Fe arrow Fe 2 positive plus 2 electron. The name of the process called oxidation. And the electron release here, release or lost by the ion will move to the p region. So it will move to the p region. It will be gained by oxygen. The electron will be gained by oxygen and water molecule. So at the q on the cathode, so we take p as a cathode. So cathode of oxygen plus 2 water molecule, they will gain 4 electron and form 4 hydroxide ion. It will form hydroxide ion. And this iron 2 ion and hydroxide ion will fuse together, will form iron 2 hydroxide. So ionic equation, iron 2 ion will fuse together with hydroxide ion 2 hydroxide ion and form iron 2 hydroxide. A green color precipitate will form. And this green color precipitate or this iron 2 hydroxide will further oxidize and form hydrated iron 3 oxide. The formula will be Fe2O3 dot XH2O. This is known as rust, and the color of the rust will be brown. So this is the rust. Rust, and the color of the rust is brown color. That's all. Thank you very much.